Hello friends, myself is Anjana Pawar from AGM College Karad. Now last lecture we study some example depends on the derivative of inverse trigonometric function. Today we again solve some example based on the same concept derivative of inverse trigonometric function. So start. What is my first? Differentiate the following with respect to x. So my first example, y is equal to cos inverse inside the bracket 1 minus x square. So I want the derivative of y is a function cos inverse inside the bracket 1 minus x square. So this is a composite form function because cos inverse, it is a standard function which is derivative is minus 1 upon square root of 1 minus x square. But here x is replaced by 1 minus x square, that is a sub function. So we can first differentiate with respect to x. That time we can find the derivative of cos inverse first, and then after again a derivative of 1 minus x square. So differentiate with respect to x. So we get dy by dx is equal to minus 1 upon square root of 1 minus x square. X, what is here x? 1 minus x square. So 1 minus x square whole square. And again a derivative of sub function. So which is derivative of 1 minus x square with respect to x. Now simplify. So minus 1 as it is square root of 1 minus. We can apply here a minus b whole square formula. So inside the bracket 1 minus 2x square plus x square, which is x raised to 4, which is the formula is a square minus 2ab plus b square. So minus 1 minus 2x square plus x raised to 4 multiply 1 is a which is a form of u minus v. So we can differentiate u minus differentiate v. So 1 is a constant, the derivative is 0 minus 2x x square, which is the derivative is 2x. So we get minus 2x because minus sign as it is 0 minus something, we get a same term. So minus 2x. Now minus minus become plus. So we get 2x divided by square root of, open the bracket. If you open the bracket, sign are changed. Plus sign get minus because bracket outside the bracket having minus sign. So if I open the bracket, plus sign given convert into minus and minus sign convert into plus. So 1 minus 1, this minus minus become plus 2x square, this plus become minus x raised to 4. Now simplify, minus minus 1 is cancel out. So we get here dy by dx is equal to 2x divided by square root of 2x square minus x raised to 4. In this term, x square is a constant. Take it outside. So we get here dy by dx is equal to 2x as it is divided by square root of x square taken outside. Inside the bracket 2 minus x square. Now square root of x square we have only x. So 2x divided by square root के बाहर x square आएगा तो x inside the bracket square root 2 minus x square. X is cancelled. So we get the final answer dy by dx is equal to 2 upon square root of 2 minus x square. So this is your final answer. Okay. Now we can start next example. Write down the next example. Y is equal to cos x inverse inside the bracket 1 upon cos 5x. 1 upon cos 5x. Okay. So this is my example, cos x inverse. We know that what is the derivative of cos x inverse, which is minus 1 upon x square root of x square minus 1. But here 1 upon cos 5x. So this we can convert into y is equal to cos x inverse inside the bracket 1 upon cos, which is sec. So sec 5x. Now we know that if here cos x and here sec, so this sec we can convert into allied angle formula, cos x inside the bracket pi by 2 minus 5x. So this is cos x inverse inside the bracket cos x pi by 2 minus 5x. Because we have a formula cos x inverse of cos x, we get only angle. So this sec we can convert into cos x, and now we can use the identity formula cos x inverse of cos x. We can write only pi by 2 minus 5x. Now it is a very easy to differentiate. So differentiate with respect to x. So we get dy by dx is equal to pi by 2 is a constant, derivative is 0, minus 5 is constant, take it outside. What is the derivative of x with respect to x? Which is 1. So your final answer is minus 5 for this example. So y is equal to cos x inverse inside the bracket 1 upon cos 5x. We can get the answer, differentiate with respect to x, the answer is minus 5. Again we can say, check this problem, cos x inverse inside the bracket 1 upon cos 5x, we can convert into sec 5x. Your aim is this sec convert into cos x term. So this cos x this sec we can write cos x in angle pi by 2 minus 5x, which is allied angle. And now we know the identity formula cos x inverse of cos x, we can write only angle which is pi by 2 minus 5x. Now next example, y is equal to cos x inverse square root of 1 plus cos x divided by 2. 1 plus cos x divided by 2. Now outside the bracket we have cos inverse. So your aim is inside the bracket the term is convert either cos or either sine. So this term convert into sine or cos, because if you convert cos we can directly use the which formula? Identity formula of cos x inverse of cos x, we get x. And if you convert into sine term, that time we have a formula sine x we can convert cos pi by 2 minus x, and again we can use cos inverse of cos, we can write only angle. So this square root we can delete it. How to delete it? So 1 plus cos x, which is a multiple angle formula. We know that cos 2x, which formula? Cos 2x is equal to, the formula is 1, 2 cos square x minus 1. Again one more formula, cos 2x, the formula is 1 minus 2 sin square x. Correct? So 1 plus cos pairing, that time we can write 2 cos square. And 1 minus cos pairing, that time we can write 2 sin square. What about angle? Whatever angle taking half angle. Whatever angle taking half angle. So your pair is 1 plus cos x. So 1 plus cos x you are convert into 2 cos square. So this cos square, cos inverse as it is square root of 1 plus cos, we can convert 2 cos square. Whatever angle taking half angle, x by 2 divided by 2. Now these two do cancel. Square root of cos square x by 2, square root is deleted because squaring term. So cos inverse inside the bracket cos x by 2. So it is a very easy to form a cos inverse of cos. That time we use only identity formula. What is our identity formula? Cos inverse of cos x, we can write only x. So here cos inverse of cos x by 2, we can write x by 2 only. So this is your y, and it is a very easy to differentiate. So differentiate with respect to x. So dy by dx is equal to 1 by 2 is constant, take it outside. What is the derivative of x with respect to x, which is 1? So your final answer is 1 by 2. Now next example, fourth example, y is equal to y is equal to tan inverse of, inside the bracket, 1 minus tan x divided by x by 2 here, 1 plus tan x by 2. We know that tan inverse derivative. What is the tan inverse derivative? Tan inverse of x derivative 1 upon 1 plus x squared. But it is a very complicated because this is a composite function. So if you take a derivative 1 plus 1 upon 1 plus x squared, and again a derivative of we can found in u upon v. So it is a very difficult. So your aim is here tan inverse. So inside the bracket term we can convert in tan term or cot term. So your aim is this term we can convert into tan term or cot term. So how to convert? So tan inverse of, as it is 1. So this one we can write tan pi by 4 because we know that tan pi by 4 value is 1. So this one we can write tan pi by 4 minus tan x by 2 as it is. Here no one is present, so we consider here 1. So again this one we can write tan pi by 4. So this one as it is plus tan pi by 4 into tan x by 2. So it is a very easy formula, tan A minus tan B divided by 1 plus tan A into tan B, which is tan A minus B. So this implies tan inverse inside the bracket tan A minus B, because here minus sign. So formula is tan A minus tan B divided by 1 plus tan A into tan B, which is pi by 4 minus x by 2. So it is a very easy to convert tan term. So we know that tan inverse of tan x, we can write only x. So here tan inverse of tan pi by 4 minus x by 2, we can write only pi by 4 minus x by 2. Now it is a very easy to differentiate with respect to x. So dy by dx is equal to pi by 4 is a constant term. So derivative is 0 minus 1 upon 2. Constant, take it outside. What is the derivative of x, which is 1? So your final answer is 1 by 2 minus 1 by 2. Now next example, fifth example. Y is equal to cos x inverse 1 upon 4 cos cube 2x minus 3 cos 2x. So again, what is your aim? This is cos x inverse. So your aim is this term we can convert into cos x या sec term. So we know that which formula? Cos 3x formula. What is the cos 3x formula? 4 cos cube x minus 3 cos x. This is my formula. So here, what is your here given term? 4 cos cube 2x minus 3 cos 2x. That means this is the formula of cos 3. Whatever angle, taking double whatever angle, multiply here, what angle here? 2x. So this term we can convert cos 6x. Correct? We can use the formula cos 3x. What is the cos 3x formula? 4 cos cube x minus 3 cos x. Given term 4 cos cube 2x minus 3 cos 2x, which is the formula of cos 3x. But here angle is 2x. So this angle we can multiply here. So this term we can convert cos 6x. So this term we can write cos x inverse as it is 1 upon cos 6x. 1 upon cos, which is sec. So cos inverse sec 6x. Now this term convert into sec term. So this sec we can convert into cos x. How? We can angle like allied angle. So this cos x inverse, this sec we can write cos x. Inside the bracket, angle we can write pi by 2 minus 6x. Pi by 2 means your ratio is changed. And cos x goes to sec, sec goes to cos x. Now this is the identity formula. Cos x inverse of cos x, we can write only angle. So here angle is pi by 2 minus 6x. This is y. Now differentiate with respect to x. So dy by dx is equal to pi by 2 is derivative is 0, minus 6 is constant, derivative of x which is 1. So your final answer is minus 6. Now next example, sixth example. Sixth example, y is equal to cot inverse sin 3x divided by 1 plus cos 3x. Again, cot inverse bracket sin 3x divided by 1 plus cos 3x. Again your aim is this term we can convert tan term or cot term. So how to convert? We have a multiple angle formula. Which multiple angle formula? Sin 2x. How to write sin 2x? Which is 2 sin x into cos x. Similarly, sin 3x. How to write? Here, whatever angle taking half angle. Correct? So this we can write 2 sin. What is the angle? 3x taking half angle 3x by 2 multiplied by cos 3x by 2. So this sin 3x we can convert multiple angle formula of this. Now here denominator pairing is 1 plus cos. Whenever it is coming 1 plus cos, we convert 2 cos square. And again whatever angle taking half angle, by using a formula 1 plus cos 2x, we can write 2 cos square x, whatever angle taking half angle. So 1 plus cos 3x, how to write? 2 cos square, whatever angle taking half angle. So numerator and denominator having all angle are same. देखो sin 3x by 2 cos 3x by 2. Here cos square 3x by 2. So all are convert into by using a multiple angle formula. So this cot as it is, this sin 3x we can write sin 3x by 2 multiply cos 3x by 2 divided by 1 plus cos 3x by 2 3x we can convert 2 cos square 3x by 2. Now simplify. How to simplify? 2 cancel. Now here cos square, here cos, 1 cos is cancelled. So remaining term cot inverse inside the bracket sin 3x by 2 divided by 1 term is remaining cos 3x by 2. So angle are same. What is sin upon cos? Which is tan. So this cot inverse inside the bracket tan 3x by 2. So this term we can convert into tan 3x by 2. This tan we can convert into cot term. How to convert? We can use the allied angle. So cot inverse of cot pi by 2 minus 3x by 2. So cot inverse of cot we can use the identity formula. So y is equal to pi by 2 minus 3x by 2. Now it is a very easy to differentiate with respect to x. Differentiate with respect to x. So dy by dx is equal to pi by 2 is constant, derivative is 0, minus 3 by 2 is constant, derivative of x with respect to x which is 1. So answer is minus 3 by 2. So dy by dx, the derivative is minus 3 by 2. This is your final answer. So that type of question in example, suppose here cot term, tan term and inside the bracket another trigonometric ratio is present, that time we convert into, suppose here tan, so this term we can convert into tan or cot. Suppose here sec, so this term we can convert into sec and cosec. Suppose here sin inverse, so this term we can convert into sin and cos. So similarly we can take next example. Seventh example. Y is equal to tan inverse square root of 1 plus cos x divided by 1 minus cos x. 1 plus cos x divided by 1 minus cos x. So again, this is tan term and I want to convert into this term in tan or cot. But before we convert, I want neglect the, we can delete the square root. So how to delete the square root? So we can again use a multiple angle formula of cos. Again here pairing is 1 plus cos and second pairing is 1 minus cos. So 1 plus cos pairing we can convert into 2 multiply cos square. And 1 minus cos we can convert into 2 multiplied by sin square. What about angle? Whatever angle, taking half angle. So here angle is x, so taking angle is x by 2. Here angle is again x, so taking half angle. Now this 2 cancel. Cos square upon sin square we can convert into cot square. So tan inverse square root of cot square x by 2. Now square root of square term we get square root is cancel out, so we get here cot x by 2. So it is this term we can convert into cot term, and this cot term we can convert into tan term by using a right angle formula. So tan inverse of tan pi by 2 minus x by 2. Again we can use here identity formula, tan inverse of tan pi by 2 minus x by 2, which is pi by 2 minus x by 2. Now differentiate with respect to x. So we get dy by dx is equal to pi by 2 is constant, take it out, derivative is 0, minus 1 by 2 is constant, derivative of x we get 1. So final answer dy by dx is equal to minus 1 by 2. I hope you understand. Now last example. So last example of this formula. What is my example? 8th example. Y is equal to sin inverse of 4 sin x plus 5 cos x divided by square root of 41. This is my example. Now sin inverse. So again here sin inverse term, or your aim is this term we can convert into sin or cos. But we do not have any formula for 4 sin x plus 5 cos x convert into sin or cos. As well as here denominator contains square root of 41. Suppose first we can separate the denominator. Sin inverse 4 upon square root of 41 multiply sin x plus 5 upon square root of 41 multiply cos x. That type of question we can solve by substitution method. So which term we can substitute here? So put cos alpha is equal to 4 upon square root of 41 and sin alpha we can convert into 5 upon square root of 41. But those two terms we can substituting only if you get identity formula. Which identity formula? Sin square alpha plus cos square alpha is equal to 1. Now check cos square alpha plus sin square alpha. We get 1. Then these two terms we can substitute in here. So check what is cos square alpha, what is cos value? 4 upon square root of 41 whole square plus what is sin square value, which is 5 upon square root of 41 whole square. So 4 square, which is 16, square root of 41 squaring neglecting, so 41 plus 5 square 25 square root of 41 squaring, which is only 41. Denominator is same. So numerator addition. 16 plus 25. We get 41 upon 41, which is 1. So this identity is proof here. So this term we can substitute in here. But before we substitute in here, we can find tan alpha. So therefore, tan alpha is equal to sin alpha divided by cos alpha. What is sin alpha value? Which is 5 upon 40 square root of 41. What is cos alpha value? 4 upon square root of 41. Which is square root of 41. Square root of 41 is cancel out. So 5 upon 4. So this implies tan alpha is equal to 5 upon 4. So this implies alpha is equal to, this tan goes that side, is tan inverse of 5 by 4. Okay. Now we can substitute in here these two terms. So y is equal to sin inverse as it is. Here sin x multiply 4 upon square root of 41, we can write cos alpha, plus cos x as it is 5 upon square root of 41, we can write sin alpha. Now this is the formula of sin A cos B plus cos A sin B, the formula of sin A plus B. So this implies sin inverse of sin A plus B. So it is easy to convert in term of sin. This term we can convert into sin by using a formula of sin A plus B. Now this is the identity. So we can write only angle, which is x plus alpha. What is alpha term? The alpha term is tan inverse 5 upon 4. Now y is equal to x plus tan inverse 5 upon 4. So it is a differentiate with respect to x. So dy by dx is equal to x derivative is 1. Tan inverse 5 upon 4 is the whole term is constant. The derivative is 0. So your answer is only 1. So that type of question we can solve by using this method. What is method? First we can denominator separate. Now whatever term here multiply of sin and cos, we can convert into cos alpha and sin alpha. But before we start write down sin alpha and cos alpha, we check the identity. If you take identity is 1, now we can convert into tan alpha and we get alpha is equal to tan inverse. And then we can simplify by using a formula of sin A plus B, या sin A minus B, या cos A plus B, या cos A minus B. And then we get the answer is dy by dx is 1. Otherwise, some question the answer also minus 1. Okay. So this is my example. Today we stop here. Now next lecture we start another example. Thank you.